Hi everyone. So my name's Sam. I'm from the Cosmos SDK. What the Cosmos SDK is a toolkit that enables you to build sovereign application-specific blockchains. So with these, I think that also kind of doesn't make sense to people sometimes. So basically, in Cosmos, you can build like your own individual blockchain. And with these chains, they're highly modularized, and they're engineered specifically for like a distinct purpose, which like enables you to be able to really specify layers and specify different bits and pieces of your blockchain. We also give you out-of-the-box modules. So, for example, we give you your accounts modules, we offer accounts, we offer staking, we offer governance, so you don't actually have to build those yourself. So it's like pulling pieces out of your tool belt to help you with the building blocks. And how we kind of see it is like a plug and play sort of vibe. A good example would be if you got like a Lego kit, and you've got a Lego kit for like a little cottage, and we provide you with like windows, walls, and you've got a small little thing, but then you can also be able to customize this. So you can make the cottage red if you wish, and you could just build a complete skyscraper. So you have a lot of choice. So you could do, as Fakud said before, you could have like a vanilla blockchain, or you could go crazy and kind of create whatever you want. So the world is sort of your oyster in a sense. But what we should do is kind of like go back a bit and kind of talk about like the functions of a blockchain. So first of all, this is like beyond Monoliths, pioneering modular blockchains with Cosmos. So we need to just go back a bit, functions of a blockchain. So we've got everything coupled together: execution, settlement, consensus, data availability. Execution is the action in which the state is updated, that updates the state correctly. So if I'm sending Faku 5 Atom, it's like the action in which changes the state. Then we have the settlement layer, which is the layer in which you can dispute and like this is where you basically settle any disputes. Consensus, get agreement, get all the validators to agree on a block. And data availability, which ensures the transaction data is available and that each node can actually get access to this at any point in time. Also, I've borrowed quite a lot of slides from Celestia. So we are we work very closely with them. So I feel like we're able to share quite a lot. So this slide is credit to Celestia. So on the left, we have like traditional monolithic chains. So we've got Ethereum, we've got Bitcoin, and everything is like piled in together, right? So you've got your validator pool doing everything. So it's quite a lot of work. And then we've got the modular on the right, which is separating execution, settlement, and consensus and data availability. So what actually that means is in Cosmos, and I'm talking from a Cosmos perspective because modular can be in Ethereum as well, a modular style, but like in this sense, we can really swap around kind of the layers. So at the moment, you can swap around your consensus engine in Cosmos. So if you built a vanilla chain, let's say with Cosmos SDK and then Comet BFT for consensus. It's been difficult up until now, but with some of the work and the tech debt that we've been doing, we've managed to separate that out. So you can plug and play with the consensus engine. So you can use rollups, or you can use, if you don't want to use Comet BFT. And then also you could use potentially CosmWasm along with the SDK for like the execution. So yeah, as I mentioned, it's very, very cool to be able to kind of customize. Actually, a good, actually, I'm going to save that for the next slide. So we have our pros. So here, it's actually, the consensus layer is actually wrapped around the execution, settlement, and data layer. So this is probably more correct, I would say. But we have, so for the monolithic approach, we have simplicity with single structure, less code, less complexity. And this is something that's like, you would struggle with modularity, is like, when you think about it, you've got these specific layers, but you have to go and talk to each of the teams if you want to create a blockchain, or like, depending on what you want to use. So there is kind of some stress around that, because having to coordinate with everyone, etc. But that's on a developer level, not like an end user. So the end user, it would be kind of great for them because you've got faster times, etc. So, but yes, this communication issue doesn't happen in the monolithic approach. Then we have security protocols are tightly integrated, and then since each transaction is processed and validated within the same unified system where consensus is also reached, there's a reduced chance of discrepancies or fraud. So as everyone knows, it's like, or feels anyway, it's a lot safer. Cons, scalability issues, which everyone's kind of talking about. Lack of flexibility, any change can affect the whole system. And then also every transaction must be processed through the same pathway, with all the transactions being validated and recorded on a single chain. So I have a bit of an analogy. So the analogy is like, you have an airport, you're really rushing to get to your airport, like it's super stressful. You know ahead of time that security is going to be long. There's only one terminal. So, you know, you get to the airport super early and like you have to wait even longer. So whoever's in charge of the airport, they're like, okay, we're going to put more gates in the airport. But then that doesn't work, because then you've got all of the air traffic that there's like another problem, right? So this kind of is representative of the scalability issues in Ethereum. And you're like, okay, and with the gates, they are representative of adding more like validators. So you're adding more validators to the pool, you think, shit, like it's gonna scale better, etc. But it's just causing more problems. So how I kind of feel the modular approach would be was like, okay, let's separate things out and let's add another terminal. And so it's like separating the air traffic, separating everything there. But it's still kind of keeping it all connected, right? It's still an airport at the end of the day. So that's kind of how I see it. Modular approach. As I mentioned, consensus layer now sits around the data availability layer. So for an example, with Celestia is actually handling the consensus for us. So modular approach, specialization in each area. I mentioned that before, this customization. Improves scalability and flexibility. You can do what you want and scale as much as you want. At the beginning I said like each, you've got many different blockchains in Cosmos. So it's really like incredibly scalable. Low fees and transaction costs. Basically, like you don't have like very high transaction fees in Cosmos. It's really, really great with that. So the cons are increased complexity, integration, and coordination, potential fragmentation if not well designed. So yeah, that's another thing you have to watch out for, is like you've got a lot of technology, people wanting to build things, but you need to really think about like the kind of ahead of time architecturally, and really plan for like the proper design. And then yeah, requires up more upfront planning. And this kind of goes into the next part of the talk, which is like kind of about like lightly on rollups, because I actually was supposed to do a talk completely on rollups, but then I got like really nerd sniped, and then there's obviously so many different types of roll-ups, and then it was just like way too much to talk about. So I'm going to do like a blog post kind of on that, so you might get to read that. So with a smart contract roll-up, that's just handling execution. So it's still just handling one of those layers. Ethereum is handling the rest. So you still have like a bit of issue with that. Then you've got a sovereign roll-up. So again, I'm using Cosmos as an example. Sovereign roll-up handles execution settlement, DA layer, such as Celestia, handling consensus and data availability. Okay, so what a roll-up is. Basically, a roll-up is a blockchain, like a special blockchain, that publishes data or transaction data to another blockchain, which handles the data availability and the ordering, right? If we go a bit lower level, what happens is a user, I'm going to create a transaction. That transaction's bytes. It's going to go to a sequencer. And I'm talking about a single sequencer in this kind of scenario. And with that, the single sequencer will create the app hash and the roll-up header. And basically, it will bundle the data together and then send that to Celestia. And that will be turned into a blob, basically. It's kind of like a little bit of a taste tester of kind of what roll-ups can be, but they're, you know, you've got shared sequences. There's a lot of different avenues you can go down. But just to keep it light, I'll just kind of go across that. But that, again, is furthering this scalability. So it's pushing the boundaries. It's like, in Cosmos, we don't really need to be even more scalable, but like, it's, again, pushing that across. So what is the SDK working on then? So as I mentioned before, there's a lot of tech debt that we have, and we've kind of cleaned up. There's like, it was a little bit of a mess before, and so what we're doing is the last year we've really been focusing on architectural changes. And one of the biggest things, I don't know if anyone saw the panel before, but on Wednesday, but I did speak about how we had a few problems, and it wasn't as flexible as everyone kind of thought it was. So, but what we've done in the last couple of months, Faku also worked on this, is we've kind of decoupled the consensus and decoupled a lot of like base app, a lot of the like integral core parts of the SDK. So it's even more modular and more flexible. So it's really, really exciting at the moment, and we're kind of I'm leading like a bank rewrite for one of the modules. So that's really exciting. And then that kind of brings me to like, why Cosmos? A lot of people, what Cosmos is and originally was, like the real narrative and the ideas behind it was to build anything. And we don't want to really have like, in my opinion anyway, we don't want to have like these two separate ecosystems. We want to be able to kind of take bits and pieces, like we do want to share, and like we do want Ethereum to be able to use a lot of our like amazing technology, and that's with like, so with products like EigenLayer, we're able to like build on top of those, build on top of EigenLayer and create AVSs. And so one of those AVSs is Ethos, which is a new project in the system, or in the ecosystem. And basically with Ethos, you're able to use like the security from Ethereum. So, and then bring that across into Cosmos. So it's actually quite funny because a lot of people are now thinking, okay, I can get the best of both worlds. And I can actually use Ethereum security because I was worried about that with an individual like blockchain within Cosmos. So people are getting more and more excited, and like, I mean, people have their kind of opinions about EigenLayer, but like EigenLayer coupled with Ethos and any other AVS is really going to be a big game changer for us, and kind of like bring and bridge that gap together, because one of our biggest problems is distribution as well. But in saying that, like, I at the end of the day, I don't think it's going to be what, like, definitely build with us, but at the same time, it's not going to be an either or. It's like, you know, build whatever. So yeah, that's the end of my talk. Any questions?
Just a very quick question. You said one of your biggest problems is distribution. Could you expand on that, please?
So, for example, like we've got Similier. This is a really good example. So, Zaki, one of like the kind of thought leaders in the ecosystem, he has this product, Similier, and there's a lot of users from Ethereum, but it lives on Osmosis. And to be able to get like people to use Osmosis or like disperse Similier, it's been really difficult because people in Ethereum, they don't necessarily use any of like the Cosmos technology. So that's what I kind of mean. It's like bridging that gap. And for Zaki, because he's like this thought leader in the ecosystem, for him not to have been able to do this, it's like quite surprising. So we're like, okay, how are we going to fix this? So that's one of the issues. That's what I meant by that.
Question?
When it will be possible, and will it be possible to merge several Cosmos chains that are Monoliths in the one modular blockchain? So at first I run the one Cosmos chain with their own validators, after second, third, and after I merge them and get the modular blockchain. Is it possible, and will it be? And if it will be, when it will be?
Do you mean to be able to have them speaking with each other, or do you mean?
So I mean like at first, for example, I made the chains that have one functionality and, for example, don't have Cosm Wasm, and the second chain have, for example, Cosm Wasm, and after I merged them in the one chain, and it became a kind of modular blockchain that have some synergy functionality, and start to use just one chain as the RAM memory, another, for example, as the hard disk driver memory, something like this.
I don't think it's possible to like actually merge the chains in one, but you can have them like, for example, a good example of two chains working together is like the roll-up chain and the data availability chain. So maybe, I don't know, Faku, is that like?
Yeah, I mean, they could merge, but they would need to like agree on
Really?
it. Yeah, so they could merge, but they would have to agree on it, and maybe it's not beneficial for them. So you would be losing these. So let's say Osmosis merges with some other chain, and Osmosis has a lot of transactions going on. So if they get another chain into their, like if they're merged with another chain, it would like the opposite of beneficial. What's it would be
inefficient. So it's like, I guess I potentially I think I'm not sure what the reasons would be to do this, but like I don't think it would be like beneficial to merge the two together and actually.
But for example, it's not about, for example, existing chains, but for example, UMI chain that have some TVL, but not so famous, for example, as Osmosis. For example, it will take interchain security from the Osmosis. Next moment, for example, Osmosis don't want to integrate some kind of the, I don't know, future contracts and merge some new chains that don't change the Osmosis but bring the functionality with new chain.
Yeah, I mean, at the moment we have like interchain shared security, so you are able to use the security from the main chain. So for example, with like Neutron, you're able to use the shared security from the hub, and there was a governance proposal for that, etc., to be able to do that.
Hi.
Hi.
Thank you for the presentation.
No worries.
One of the narratives for the last couple of years was to build L1s and L2s EVM compatible, right? And well, there was some Cosmos called EVM OS, EVMOS, something like this.
Oh, EVMOS, yeah.
EVMOS, something like this. Why do you think that it didn't actually succeed when actually worked for other projects to launch an EVM compatible? Thanks.
I think that's a little bit of a loaded question. I think I'm not sure if it's down to the actual, I still think it's a good product, but I think it's down to the actual team, etc. like this. So there are other teams now like forking the EVMOS, and like, I guess let's just see how that kind of goes, right? So I do think it was down to maybe the team in the project not having enough, yeah.
Anyone else? Big ass round of applause for Samantha.